What is the period? Okay. All right, take note, horizontal rows are the periods. And Richelle, how about the vertical columns? What are they called? Okay, so yeah, those are basic stuff. What is common within a group, Ariana?
Number of electrons.
So these are, I think this, you should have done all this before. So this, as I said, this is a group, vertical is a group, and they have the same number of valence electrons. Okay, so for example, this is the old version, but this is group 17. Group 17 all have 7 valence electrons. How about period? Richelle, what is common within a period? Let's say period 2, all these guys, period 2. What is common among them? I want. Okay, but let's be a bit more precise. Now, period, elements in the same period means same number of electron shells. Can Richelle, does that ring a bell? So if you are in period 2, let's say you are lithium, then it has two filled electron shells, just like fluorine in period 2 as well. Oh, actually, I don't know whether you heard just now, I told them we are interested in groups 1, 17, 18, and this whole chunk there. From Asia, what is this whole chunk here? They are called now, these are your transition elements. Can, so yeah, for O levels, we're interested in group 1, 17, 18, and a bit about transition elements. But let's quickly go through group 1. Come, Sabrina, tell me. Oh, before I ask you. Okay, a few things you need to take note of. Let's look at group 1. We are interested in a few properties. You need to know MP and BP, how do they change down the group? You are interested about density. How do they change down the group? You are interested about chemical reactivity. Down the group, and of course, there are some other specific properties for that group. So think about this for the other groups as well. And a quick reminder, these two are physical properties. In case your exam question asks you physical properties, think about them. Okay, Sabrina, tell me, for group 1, how do MP and BP change downwards?
Down the grid, the MP and BP decreases.
Okay. Guys, I always work down the group. Okay, let's keep the context. So from lithium to sodium to potassium, MP, BP decrease. No need to know the reason. That one is not for O levels. Come, Ethan, how about density down the group?
Density increases.
Okay, good. Guys, you have to remember. You have to remember, but I can't give. I don't think there's a point giving you the explanation, but you have to remember. RNA chemical reactivity. Yes. So lithium is the least reactive, and by right, francium is the most reactive in group one. Yeah, of course, you can add that in if you want. Okay, what else? Oh, no, there's one more thing I missed out. Now, one thing that you may be asked is metallic character. And of course, the opposite will be what we call non-metallic character. So as you go downwards, yes, I know they are all metals, but there are different extents to being metals. As you go downwards, do they become more metal or less metal? That is the question. But before we answer that, Sabrina, what is meant by metallic character? How do you define metallic character? Sabrina?
I don't know.
Oh, you didn't write down last week. Dylan, how do you define metallic character? What makes something metal?
The electrons.
What about that? What about electrons?
The number of valence electrons.
Okay. I mean, it's linked to that, but let's be a bit direct. Basically, this is the direct definition of metallic character. Its tendency to lose electrons. Metals love to lose electrons. Okay, guys, try to remember this. Now, in contrast, non-metallic character will be the opposite, tendency to gain electrons. But let's go back to our story here. Come Arena, as you go down the group one, metallic character, increases. So in simple words, francium loves to lose electrons much more than, let's say, lithium. Okay, I hope you can realize it means non-metallic character is the opposite. Okay, as you go downwards, non-metallic character decreases. So I repeat, these two are always in contrast. Come group one, Ariana, what other properties are there that I haven't said?
Soft metal.
Good. Guys, you need to know they are soft metals. So soft that you can cut with a knife because your knife is harder than them. Oh, but of course, in this case, you do not need to know who is softer, who is harder. Not for all levels at least. Okay. Come, Dylan, any other properties about group one? Anything about their appearance?
Silver color.
Yep. Okay, so all of them are silvery metals or silver color metals. Oh, one more thing though. Just now I didn't add. Let's go back to density. Now, no doubt the density increases down the group, but I also need you to know, still in general, group 1 matters have relatively low density compared to other matters. Yep, that's about it. Okay, very simple stuff. The only difficulty is to remember them. Okay, now let's copy the same thing and move over to the other group. Any questions? Oh, I hope I'm not too fast. All right, those at home, if you have questions, please voice out as well. Okay, let's quickly jump to group 17. Okay, so yes, let's look at group 17. And I ask the same questions. Okay, come. Dylan, MPBP, group 17. Yes. Now, as always, it's down the group, from flooring all the way to that last one, which I hardly get to pronounce it at all. Density, Arena. Yes, increases down as well. Ethan, chemical reactivity, group 17.
Decreases.
Okay, good. Sabrina, metallic character. Sabrina.
Increases.
Okay, this is a trick question. Okay, now. Angel and Rachel, I assume you know the staircase between matters and non-matters. Can you remember staircase? Okay, draw out on your own periodic table. You need to get it right. Of course, you can compare against mine. Can Arena can get it right this time? Now, the staircase is important because it can help you to remember, provided you get the staircase right. You notice something right. What's right at the bottom? Who is this guy here? Is this a matter or non-matter? Richard? Yeah. Okay. On the left side of the staircase, matter. And everything above in group 17 are non-matter. So that answers your question already. Metallic character increases down the group. Okay, yeah, going from non-matters to matters. And as I said earlier, non-metallic character is in reverse. So it decreases down the group. But what else? I did mention a few more things last week. Come, Arena, this group 17 is very special. What are the states for fluorine and chlorine, Arena? Yep. Room temperature and pressure, they are gases. And how about bromine, Angel? Liquid, solid, gas. Okay, take note. Bromine is a liquid at room temperature and pressure. The rest are solids. Now, this is useful because gases to liquids to solids, that already tell you what MPBP increases. obviously gases have low MP and BP. Liquids higher, solids even higher. So that already answers this. And it also answers gases have the lowest density, solids have the highest. So that already tells you density increases as you go downwards. Gases to liquid to solid, density increases. Okay, so yep, please remember that too. That's for group 7 then. Lastly, just one very special property. Okay, come Ariana, what's the one property I haven't mentioned? Good. Good. As you go downwards, color intensity increases. It becomes darker and darker and darker. Come Dylan, quickly tell me. Fluorine, color. Okay, pale yellow. It comes up once in a long while, so it's up to you whether you want to remember or not. So fluorine, pale yellow. Sabrina, chlorine.
Chlorine is like greenish yellow.
Okay, fine, greenish yellow. If you don't like that, you can call it yellowish green. Ethan, bromine.
Reddish brown. Reddish brown.
Hey, this one, everyone please remember, reddish brown. It will come back again in another chapter. Ariana, iodine.
Okay.
Okay. Astatine, I think I told them last week. Hardly, in fact, no one has seen it before in adequate quantities. So it's probably black. Probably. So if you can remember the colors, but like I say, among them, the most important one to remember is this bromine, because you see this guy again. If you forget the rest, okay, so be it. Hopefully they don't come out. Okay, so yeah, that is group 17. Group 18, there's nothing much to say. There's nothing much to ask either. Group 18. Now, first thing first, they are called noble gases. So yes, of course, all are gases. How about, okay, I'm not going to talk about MPBP or density, because it's not exactly part of the syllabus. But how about chemical reactivity? Come, Angel, anything about chemical reactivity for group 18? Yes, good. Non-reactive. Yeah, why, Angel? Okay. Fully filled valence shell. And that means they simply love this model statement, stable electronic configuration has been achieved. Let me see anything else. That's about it for group 18. Yeah, probably they won't ask anything else. Okay, because it's really special. And in case you are wondering about metallic character, non-metallic character, nothing much to say about them because they don't like to gain electrons, they don't like to lose electrons either. So nothing much of each. Okay, they hardly have any so-called metallic or non-metallic character. Okay, now lastly, transition elements, this whole chunk here. First thing, they are all metals. I hope you realize that. Okay, where should I write it? Yep, all matters. Okay, come, Arena, what can you tell me about that?
Yeah, variable oxidation states.
Okay, just note this for now, even though you haven't really touched on oxidation states, except for Angel. Okay, for now, I'll tell you oxidation states means another name for that is valency. Or number of electrons in the valence shell. Now, the only example for now is iron. Iron is right here. Richel, iron, what are the charges for iron? It can be iron. It can be iron 2+ or 3+. That is meant by variable oxidation states. They have different number of electrons in the valence shell. Actually, same for the rest, even though you hardly encounter them. Now, Dylan, for transition elements, are they all solids?
But they're all solid except for mercury.
Good. Good. Take note for those who did not come last week. All right, only mercury is liquid at room temperature and pressure. The rest are all solids. Sabrina, what else about the transition elements?
The compounds are colored.
Good. Yeah, compounds are colored. I emphasize compounds. Their elements may not be colored. Most of them are silvery, except for a few, but their compounds are quite colorful. I'll give you one example. One nice example. This is potassium permanganate or potassium manganate 7. Oh, why I cite this example, you will probably encounter this even in your practical. So I'll give you the name as well, potassium manganate 7. Okay, make sure you know where's manganese. It's right in the center. Manganese is right here. Manganese. Now, the important thing to know is this. It has 3 elements inside. Potassium. Does it contribute any color to the compound? Answer is no. Oxygen. Oxygen, you don't see color compounds. I mean, oxygen doesn't contribute color. So the important thing is this. This is the one that contributes or makes. Purple. Remember purple. It's the manganese that gives it the color. Not potassium, not oxygen. I repeat, remember purple. If you ever see purple in your test exam, in your practical, 99%, this is the compound. This is the solution. Normally, they don't give you the solid, it's a solution. So take note, I repeat, purple 99% is this guy here that you're looking at, especially practical. Okay, Ethan, any other properties about them?
Relatively high density.
Good. Remember, they are all metals, relatively high densities. Iron, you use it every day. I mean, gold, you probably don't see every day, but yeah, the density is very high. Okay, Arena, any other property? Yep. Relatively high MP and PP. You're talking about at least 400, the lowest, if about 500, it can go all the way to a few thousands. Okay, whereas for group 1 is only about less than 100 or about 100 plus degrees Celsius for MP. Let me see, did I miss out anything? Okay, I think that's about it, except for one last thing. Oh, any questions? No? Okay, one last thing. Sometimes they'll ask you, what happens as you go across the period from left to right? Now, essentially, two things they can ask. One is metallic character, and of course, the opposite, non-metallic character. Come, Dylan, left to right, metallic character.
Metallic character decreases.
Yes. I think this one is quite easy to see. Look at the left-hand side, lithium, beryllium, metal. But suddenly you jump here, boron, no more metal, carbon, no more metal. So you should be able to deduce metallic character decreases, and of course, in contrast, non-metallic character increases. Yeah, hopefully not a problem. Okay, guys, any questions? No? Now I'll pass you your worksheets. Okay, those at home, the worksheet is already in your Telegram group chat, so start working on it. Dylan. Just a note, this is the old version. So look at this, for example, right here, H, sorry, G. They put group 17. Now you need to know it as group, sorry, it's supposed to be group 17. This is group 17. Group 0 is now group 18. I think there are a few more, but let me see if I can find them. Okay, never mind. Just take note of this one first. This is group 17. Group 0 is group 18 now. Okay, likewise for MCQ number 1, group 0 is group 18.
Yes, question 3.
Question 3, MCQ.
Yeah.
Okay. Yeah, no doubt you haven't really learned about oxidizing agent. But look at the rest then. Is it you haven't learned about reducing agent either. Is it in period 1?
No.
No. Does it react with water to give oxygen?
Uh, okay.
Okay, remember last week we did mention about matters and water, right?
Oh yeah.
If you have a matter and it reacts with water, if it reacts with water, what do you get? You remember? You will get a matter hydroxide plus H2. Okay, yeah, we did go through this week, even though officially it's not in the chapter yet. So yeah, of course, this is wrong too. But I'll give you the answer anyway on number 3, even though it's not covered yet. Or have you done it, Angel? What's the answer? It's a stronger reducing agent than sodium. Oh, Angel, seems like you have to go through this very soon. Yeah, just for your info, strong reducing agent means what? Means that it likes to oxidize. Agree? So it means that francium likes to oxidize. Itself likes to oxidize. That's why it can reduce other people, because it likes to oxidize itself. But what's the meaning of oxidize? Oxidize means yes. All right. And francium likes to lose electrons. Okay, same thing for number 6, in case you haven't figured out. This is group 17. Richard, any question? Oh, Angel, are you able to do question 3? Have you done it already? Oh, can handle. Okay. Now easier, okay. Arena, all done. Okay, that's good. Now, guys, I just want to add a couple of points here. Now, when I was going through group one, I did mention chemical reactivity. But what exactly does it mean, chemical reactivity? Well, of course, in simple terms, it means that it likes to react with, let's say, water. It likes to react with acid. Yeah, those are okay. Those are valid definition or valid descriptions. But let me give you an alternative description of chemical reactivity. Now, in this case, we're looking at group one. they are all matters. So I can also describe reactivity as tendency to become what? Cations. This is another way to look at it. And I said that francium is the most reactive metal, then you can interpret it as it loves to become cations and cation the most. Okay, so think about this description of reactivity and alternative viewpoint. As you go downwards, they like to become cations more and more, rather than remain as their elements. Now, in contrast, if you look at group 17, we did also mention chemical reactivity for group 17. Are you able to provide an alternative description as well, group 17? How do you want to describe chemical reactivity in group 17? So if I go to group 17 here, yeah, I did use the word chemical reactivity too. How do I want to describe it? Now, just now, we were looking at matters, but look at group 17. 1, 2, 3, 4, 5. 5 are non-matters. Only the last guy at the bottom, if you can even find it in the world, is a matter. Okay, so therefore, I can have an alternative definition. All right, it means that the tendency to become anions. Remember, they are non-matters, so that's why I use the term anions here. In other words, that also means fluorine is right at the top. I also said that reactivity decreases of fluorine. In fact, it's the most, it loves to become anion the most. Instead of staying as an elemental form, it loves to become an anion. So yeah, there's another, this is basically these are alternative viewpoints. But of course, the same rules apply. It loves to react with water. It loves to react with metals, for example. Okay, Dylan, all that? Not yet. Richard. Okay. Come, let's just go through a few. I know there are a few difficult questions that I really haven't touched on a lot just now, but at least get the basics correct. Ethan, Sabrina, I assume you are done. If not, let me know. Okay, come quickly. Let's go through the whole chunk here. True or false? Michelle, A. Michelle? Are they arranged by relative atomic mass? No, because, yeah, you're right. Because they're arranged by not exactly. Now, go back to your periodic table. Guys, in case you've forgotten what is what, look, you can look at the key here. The top number is proton number, proton atomic number. The bottom number is relative atomic mass. All right. So if you look carefully, you start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the arrangement, and that is based on proton number. So I repeat, the periodic table is arranged based on the proton number. It follows 13, 14, 15, 16, 17, 18, 19, 20, and so on. B, Arena? When they say across a period, by default it's left to right. Yeah, sorry. Yeah, of course not. They decrease in metallic property or metallic character. C, Dylan?
False.
False. Guys, I'll go through a bit quickly. Of course, if you have questions to ask, especially if you get it wrong. D, danger. More metallic because it becomes more difficult for them to lose electrons. Okay, when you say that become more metallic, yeah, you're right. Going down the group, they become more metallic. But that also means it becomes easier for them to lose electrons. Remember, being metallic means easy to lose electrons. They love to lose electrons. That's why they are metals. Okay, come Sabrina, E.
False.
Okay, why?
Is it supposed to be elements in the same group?
Yes. Okay, good. Elements in the same group have similar chemical properties. Take note of it, even though I didn't express it earlier, because they're the same number of valence electrons. Okay, so take note of E. All right, E can come up. It has come up before for O levels. Ethan, F.
True.
Yes, good. Michelle, G. Yeah, should be false. As you go down the group, your element should become less active or less reactive. RNRH.
True.
Dylan, I.
True.
Okay. Angel, J. False. Okay, what? Angel. Yes. High densities. So yeah, be very clear about all this. I mean, no doubt it will come up. True or false will not come up for your test or exams, but you need to know all the concepts here. Okay, come, let's move on. All right, come, MCQ number 1, Sabrina.
A.
No problem there, I hope, for anyone. Ethan 2.
C.
Okay, again, I hope no problem for anyone. If there is, voice out. Okay, look at number 4. Michelle. B. Esther. Okay, good. Okay, guys, I didn't mention today, even though I mentioned last week. Take note of the word halide. You're supposed to know what it is. Now, as I said earlier, group 17 elements are called halogens. Group 17 are called halogens, but their ions are called halides. We need to know that word, halides. So fluoride, chloride, bromide, iodide, astatite, they are all halides. Okay, make sure you know this term. The halogens refer to their elemental forms. Okay, let's go back. Okay, Ariana, 5. Yep, try to get it right. Okay, number 6. Yep, Dylan.
C.
Okay, if you get it wrong or you have questions to ask. Okay, now, Michelle, all right. Now look at section V number 1. Okay, which is our place? Asia, 1A. Sorry. Okay, why? Okay, good. Guys, make sure you see that. 2 valence electrons, the rest 1. Sabrina, 1B.
Neon.
Okay, why?
It has a full electronic configuration compared to the rest.
Okay, good. Fully filled. Or well, I mean, you can follow what she said, but it has a fully filled valence shell. Make sure you have the word valence there. Okay, the rest do not. Now for number 2, it's a bit difficult to ask you to describe. So I show you the answers here. Check your own answers. If you got any wrong, to let me know. Oh, Dylan, everything correct? Okay. Ariana?
V and X.
Oh, V and X. Okay, let's take a look at V. V is an electronic configuration of 2, 2. 2, 2 means what? It has 2 valence electrons. And because 2, 2 means 2 shells. All right, so 2 shells means period 2. This is period 1, this is period 2. And of course, 2 valence electrons means group 2. This is group 1, this is group 2. Okay, so 2, 2 must be here. Okay, Ariana, try not to get it wrong. The other one is X, is it? X, it forms an ion X3 minus with electronic configuration 2A. Now, X3 minus is an anion. In other words, it must have gained 3 electrons. It has gained 3 electrons, right? So therefore, in its original elemental form, X will have a configuration of 2, 8, and 5. 8 minus 3 will give you 5. Okay, so where is group 15? Because it has the elemental form has 5 valence electrons. So basically this is group. All right. 13, 14, 15, 16, 17, 18. And if you look at group 15, then it's this group. And what else do you know? It has 3 shells, 1, 2, and 3. So 1, 2, and 3. Therefore, there's nowhere to go. Okay, the rest, any other questions for number 2? No, fine. Okay, let's Michelle, all right. Okay, number 3. Number 3 is a bit more difficult, but it's a standard question. Guys, by right, you should be able to write your equation out. You should not screw up on that. Because they already told you this is a product. Water is a product. And chlorine gas is a product. I mean, of course, I assume your English is up to this standard. It can be made. So chlorine gas is a product too. Reactant? Well, they already told you. HCl, manganese. Those are reactants. So the only thing you need to do is make sure your formulas are correct. Make sure your formulas are correct and make sure it's balanced. I hope no problem with balancing. Now, even though the question didn't ask for state symbols, but let's try. HCl always equals, well, they did use the word acid, right? I believe hydrochloric acid. Once you see the word acid, automatically it's equals. Manganese oxide. Do you remember your solubility rules? Will you expect it to be soluble in water? No way. Okay, so it's going to be solid. Now, what did we stop? What did we mention about chlorine gas? Yeah, I already used the word gas, right? Now, water is a bit tricky. It depends on the conditions here. You notice there's heat, right? So it depends, but let's assume that we are talking about room temperature and pressure, then it's liquid. But under these conditions, I would expect it to be gas. So it can be a gas too. Oh, sorry, I misread it. It should be a liquid. The reason is the reaction doesn't take place here. The reaction takes place here. Oh, but there's a heat. Okay, but never mind. I don't imagine everything will boil away, so leave it as a liquid. Manganese chloride. Dylan, what do you expect the state symbol to be? Yep. Remember your chlorides. You would expect this to be soluble. Okay, so yep, that's that. Okay, for part 2, only Angel need to answer. Is it a redox? Why? Okay, good. Mhm.
Transform to
Two.
yes.
Okay, so OS stands for oxidation state. Right, Cl increases. What is here? Yeah, increases from -1 to 0. Whereas for manganese, oxidation state decreases from +4 to +2. Okay, but sooner or later you have to do this as well. Okay, I'll just clarify. OS stands for oxidation state. Yeah, I hope to go through this very soon on the redox reactions. Okay, but actually for this entire worksheet, this is the question I'm most interested in. Because I can bet you it's going to come out. Almost 100%. Something like this will come out for B. Now, Arena, what is form at T and R?
So we can only include formats.
At T, okay.
Then IoT
Mhm.
for at our
Okay, maybe I hope you have heard her. If not, I'll just repeat. Now, what is going to form at T? Bromine. Take note, Okay, I didn't say this just now, but I hope you realize an entire chunk of group 17 are diatomic. So if they are elemental form, F is F2, Cl is Cl2, Br2, I2, Ag2. If they are in elemental form, it's always 2, 2, 2, 2, 2. So try not to make that mistake. If they are in a compound, then different story. But elemental form is like that. So go back here. Yep, at T, Br2 is formed. But what state do you think it is at? This is the tricky part. Do you notice the heating? Bromine is quite volatile. So because of the heat, you would expect it to be in vapor form. Now for R, Ariana is correct too. I2. Now, okay guys, let's go back all the way to your chemical bonding and structure. All these are simple molecules. Therefore, you will expect them to have low boiling point. So if you just apply some heat, it vaporizes easily. So you will expect it to be a gas as well. Okay, Ariana, let's just take note. But you still have the right equations. So what's the equation? Come, especially for Rochelle and Angel, take note. If I look at this, what is coming in here? Cl2. Okay, remember you produce Cl2. It's a gas, so it's going to get transferred here. What else is there? KBr. Okay. So they are going to react. Okay, so make sure you know this. I'm confident it's going to come out. So you have Cl2. Yes. You have KBr equals. It's still soaked in the ceramic wool, by the way. What happens is this. Make sure you can write this fraction. You get Br2 coming out. Now, because of the heat, it is in vapor form. And you have KCl form. Balance it. And Dylan, make sure you get the equation correct. How about the explanation? Oh yeah, no need to write. I just write to show you. Explanation. Oh yeah, Aaron, how do you explain this?
Bromine in potassium bromide as its chlorine.
Okay, good. So how do I write this? Chlorine is more reactive than bromine. How do I know? That's what we mentioned that's what we discussed in group 17. The higher the group, higher the position in the group, the more reactive it is. Remember that. So Cl2 displaces. Try to be mindful of how you use the word displaces. Displaces Br2 from KBr. Okay, and I want you to pay attention because the sky is in elemental form. It likes to become an anion. That's what I mentioned earlier. It doesn't like to stay as an elemental form. It likes to become chloride. But of course, you don't have to write that in your answer. Okay, so Cl2 is more reactive than bromine, so therefore Cl becomes the chloride. Bromine is forced to back into its elemental form. Okay, can. Now, lastly, before I end the lesson here, this reaction has a name. This is called a displacement reaction. No surprise there. Okay, I'll finish up with the other reaction as well. How about I2? Why is I2 produced at the, what is it? R. Now what happens is this, go back to our diagram. Now Cl2 comes in at the front, but what happens at T? Now T I have something else. T I have bromine vapor. Remember, bromine is produced at P. So at the section T, now I have bromine. And bromine is going to meet up with Ki. Can. So same thing, write your equation out. So for this case, you have bromine. Yeah, I know, no need to write the state symbols, but it's good to be mindful of them. Plus Ki, right? Yeah, Ki. Ki is equals, which is soaked in the ceramic wool. And then you force iodine to come out. While bromine stays as bromide at the ceramic wool. All right, so same thing, fill it, balance it, balance it. Actually, I can write exactly almost the same words now. You probably know how to write it by now. I just use exactly the same words. BR, except in this case, I'm interested in BR and versus I. BR is more reactive than I. So BR2 displaces I2 from Ki. Yeah, that's all. Oh, of course, not surprisingly, that is also a displacement reaction. These two are displacement reactions. Try to remember this. I can bet you it's going to come up. Displacement somehow. Probably something like this, something like this. Okay, lastly, maybe I just finish on part C. Why is this performed in the allow him to come back in? Let's see. Yeah. Okay, let me just share with you again. Okay, let's just finish off this one. Why is it carried out in the fume hood? Dylan?
Bromine gas is toxic.
Okay, not bad, not bad. Not bad, but he didn't give you the complete answer. Come guys, can you add in, go back to your periodic table again? I did not mention this because it doesn't come out all the time. Go back to your group 17. Let's add one more property. All group 17 elements are toxic. But let's be a bit more specific, are toxic in their elemental forms. All of them. This is not tested all the time, once in a long while. So F2, Cl2, Br2, I2, At2, if you can find it, all of them are toxic, especially in the vapor form. But But don't forget, how about NaCl? Now it's in a compound form already. Is it toxic? I mean, it's bad for health, but it's not exactly toxic. So just be a bit mindful about that. They are only toxic in their elemental forms. F2, Cl2, Br2. But once in a compound form like sodium fluoride, potassium fluoride, they are relatively safe. And so just be a bit mindful of that. Okay, yeah, that was the answer, by the way. Okay, basically, I want you to include, okay, by what are you playing in this case? You have Cl2, you have Br2, you have I2, and some more, you would also apply heat to them. So you tend to find them in vapor in this experiment are toxic. I mean, of course, you want to play with the liquid or solid cider, but the vapors are especially bad. Okay, if you haven't finished the last question, do so, and we'll go through this next week. All right, any final questions for today? No? Sabrina, Ethan, any questions?
No.
No.
Okay, I'll put up the video for this, the recording for this as well. Ethan, in case you need to go through, you can watch the video recording. Okay, so yeah, I'll end the lesson here. See you next week.
End of year.
Oh, yes. Yours as well. Oh, okay. I'll tell you what, guys. You all don't need to return to your school, right? To you? You need to return to your school. Okay. I'll return to you next week.
Yeah.
Let me take a look. Okay, bye. Yes, I'll give it back to you. Bye, Michelle. Okay. Yeah, actually, I mentioned all those things.
You need my chemistry paper.
You have it now?
No, I didn't bring it.
Oh,
I bring it. Wait.
yeah, next Saturday.
Okay, bye-bye.
Bye.
Yeah, I'm coming tomorrow.
Yes. Bye.